probably all know what this is, and most of you will have probably thrown a Frisbee before. But if you've been in the park, it might not have worked that well as you wanted, and the Frisbee just flew over to the side or just didn't go really far. So I'm going to tell you the science behind how a Frisbee flies, so you can then go into the park and impress your friends with your new sciencey Frisbee skills. And to answer the question of how a Frisbee flies, it is important to ask the question first, why shouldn't a Frisbee fly? And first of all, of course, there's gravity. And we kind of tend to forget about gravity a lot because it's just there all the time, but gravity is the force that pulls everything towards the middle of the Earth. And practically speaking, given we are standing on the Earth, it just means that it pulls everything towards the ground. So how do we overcome gravity? We have to apply a force to the Frisbee that counteracts the force of gravity, meaning we have to throw it. And of course, this is not everything. For example, I'm pretty sure Jenny wouldn't like if I threw a Frisbee in here, so I'm going to use this. If I throw this with a lot of force, it didn't really go anywhere. And that is because air. And air is all around us, and we also tend to forget that it exists. But on light objects and on objects that move fast, air has a lot of influence on how they fly. So it will slow down the object a lot, and it depends on how much surface of attack you present to that air. So if I throw this like this, then the air will be able to hit all the surface and will slow it down a lot. So of course we want to throw it like this, and as you can see, with a lot less force, it flows a lot further. Another really important thing and really another important reason to throw a Frisbee on one plane is because of lift. And as you may have noticed, the edge of a Frisbee is slightly curved, and it is similar to an airplane wing. So the lift is just a force that acts perpendicular to the airflow. So if the Frisbee is flowing like that, it will push the Frisbee up. And that is of course good if we want to fly, if we want to let the Frisbee fly. But the lift doesn't only depend on the shape of the Frisbee, it also depends on the angle of attack. And the angle of attack means that as we release the Frisbee, we can, for example, release it with a steep positive angle or a negative angle. A positive angle means that the air hits the bottom of the Frisbee and that will push the Frisbee up, while a negative angle of attack will hit the air will hit the top of the Frisbee and push it down. So obviously we want a little bit of a steep angle, but not too much, because if we throw it too steep, it will just have a lot of friction again and slow the Frisbee down a lot. Now, throwing on one plane, as we've seen, is very important. First, to reduce the air friction, and also to increase the lift of the Frisbee. But it's not as easy as you might think. For example, if I just throw this Frisbee up, you'll see it turns and wobbles. And that, of course, is not good. When I'm throwing the Frisbee and it will start wobbling, then it will have a lot of air friction and less lift. So we want to keep it on one plane. And how do we do that? By spinning it. And as you can see, when I spin the Frisbee, it stays on the plane that I've released it on, and the way it is spinning. It will not change its orientation. And that is because of angular momentum. And this is the case with all spinning objects. This is why spinning tops work, for example. And as you might know as a kid, the more you spin a top spinner, the longer it will go. And the same thing applies for a Frisbee. So say you want to throw the Frisbee really far and really well, you have to give it a good spin, throw it of course hard, and you have to give it a slight steep angle of attack, so that it will fly upwards. And that is the key to throwing a Frisbee.